This is section 3.2 on basic differentiation rules and rates of change. So what we're going to learn is that the limit process showed us how a derivative existed. And the idea was, for a derivative, we had a function, and with that function we had 2 points, and we were trying to find the slope of a tangent line, and we used 2 points. We used x and x plus h, and then we had the definition of a derivative stemmed from that, which was the limit as h approaches 0. In other words, we move that other point closer and closer, of f of x plus h minus f of x all over h. So that's the version that I like of the derivative. They use delta x, but the idea is visually this second point moved closer and closer to the first point, and we were able to find the slope of the graph at one point. So instantaneous rate of change, slope of the graph at a point, slope of the tangent line, derivative, all of these are the same thing. Well, this limit process, if you notice from the last section, this limit process takes a long time, and it's many, many steps. And what we're going to do in this section is we're going to start noticing that we can shortcut the limit process. Okay, I want to be extremely clear. If it says using the definition of derivative, if the problem says using the definition of derivative, you must use the limit process. That's so important that I'm going to write it down here right now. Okay, so I just wrote it right here. It says if the problem says definition of derivative in it, you must use the limit process, and I cannot emphasize this enough. Anytime it says definition of derivative, you must use the limit process, which is this limit as h approaches 0 of f of x plus h minus f of x all over h. That's only going to be probably about 2 problems on the test, though. The rest of the problems, when it says find the derivative, find the slope of the tangent line, find the slope of the graph, find the instantaneous rate of change, you will be able to use these rules that we learn in this section, okay? So just read the problem. If it just says find the derivative, use these rules. What rules am I talking about? Well, we're going to learn the constant rule, the power rule, constant multiple rule, sum and difference rules. We'll learn some of the derivatives of our trigonometric functions, sine and cosine. We'll learn the derivative of exponential functions, and then we'll relate it to rates of change, because we already said that a derivative is the same thing as an instantaneous rate of change. So we'll see some applications of that, okay? So the first rule is the constant rule. What's the constant rule say? The constant rule says the derivative of any constant, a constant is just a number, is 0. And let's see why that has to be true. Think about a function like f of x equals 2. If this is f of x equals 2, it would be y equals 2. So any of your points, no matter what point you pick, no matter what x value you pick, your y value is 2. If your y value is always 2, that would create a horizontal line. Well, we know the slope of any horizontal line is 0. No matter where you go, the slope of a horizontal line is 0. And if the slope is 0, that means the derivative is 0. So no matter what it is, whether it's f of x equals 2 or negative 10 or even square root of 2 is a constant, right? Anytime you have a constant function and you take your derivative, because it's a horizontal line, no matter where you evaluate it, the derivative of a constant is 0. So we do need to show work here. We can't, if we're using the rules, we do need to show work. We don't need to use the limit definition anymore, which, by the way, this works with the limit definition. You can see the proof in the course, or in the e-text. They show the limit definition proof of this, but I don't need you to see it, okay? Or I don't need you to write it anyways. So it says, find the derivative of the following functions. A is y equals 7. The answer is 0. Again, we can't just put 0. We have to justify it. Why did I put 0? Because this is a constant. You're going to find that with every single one of these. What about the derivative of 0? Well, it is also a constant, and so the answer has to be 0. Let me go over to the answer blank and put in a 0, okay? The next one says s of t equals negative 3. Again, this is a constant. So saying it's a constant is showing my work. If you didn't put that it was a constant, you would have to use the limit definition, which I'm sure you don't want to do. How about k times pi squared? Notice, and it says k is a constant. Well, pi squared is also a number. Pi is 3.1415917. It goes on forever, okay? Pi is a constant, so that number squared is still a number. times k, which is a number, is still a number. So this is still a constant. So even though it looks weird, this is a constant, and the derivative of any constant, because a constant is a horizontal line, is 0. So the answer for every single one of these would be 0. Notice it didn't say using the definition of derivative, so I just went ahead and used the derivative rules.